In this video, we're going to explore the middle percent and trying to find the cutoff values that go with that. So this is a normal distribution, just using z-scores here for simplicity. If you were using GeoGebra, Desmos, or Excel, you have to enter in your actual mean and standard deviation to get the right values. But here it just helps me place the lines and give you a model here just to show you. So this one question I had was the middle 40%. Let's just kind of try to figure that out first. And so if I had the middle 40%, I know I need to be 20% this way to the right and 20% to the left of this middle line here of the mean. So I'm just going to draw in a line here that is going to be pretty close, but I don't know exactly. Be right about there, and we'll look at it in GeoGebra also. So it's kind of about there, but again, it's not so precise. I can't tell. I need to use technology to help me out. But this would be the middle 40%. I have 20% on either side. So this is 20% and this is 20%, giving me the total of 40%. But when I use technology, I can't just put a lower bound for percent and an upper bound. I have to do them separately. So I need to know exactly what these, what this to the left is how I usually enter it in. What is over here? What percentage is left? Well, if this whole thing is 50%, right, from the tail to the middle would be 50%, this piece is going to be 30%. So to find this x value, I can go to GeoGebra and I can enter in 0.3 for 30%. And the x value that I end up getting here is negative 0.5244. Now these are z-scores, that's why it's so kind of small and it's showing as negative. But if you had actual scores of a test or something like that, I'll do a problem as well for an example. It would look a little different. But we're going to just go ahead and rewrite that on our paper so we remember it. Okay, so I've jotted that down and I'm just rounding off. So the next one is, if I want to use that same approach and use the left bound, then I could take the 50% line here and add 20%, and that would give me this whole, in a different color here, but this area all right here would be 70%. Okay, so that whole thing would be 70%. I could do it that way with a left bound. I'll show you that first. Or you could just use the mirror image and knowing this is 30% and make it have a right bound. You can do that in GeoGebra, but not Desmos. So if we go look over here and change this to be 7.7, we will get, it's going to mirror image, 0.5244. So it's just the positive version. That's why it's easy to see with the z-scores. But if I wanted to leave it as the 0.3 and just change the bound, I could, let me move this out of the way here, I could change it to have that be instead of a left tail, we could do it as a right tail and get the same answer. So we get 0.52 either way. and just jot that down. So that would be my X values. That's the lower bound and the upper bound. Now in Desmos, it looks a little bit different. An example of that in a separate video.